Good morning, everyone. Before I begin, I just want to recognize my colleagues, Harold Klomler and Suresh Rao, from many of the components that are going to appear in the presentation. And moving forward, I'm going to start or open up the presentation by discussing very briefly this perspective of social, ecological, technical systems. And then I'm going to move from there to look at risk and resilience challenges as they pertain to infrastructure and climate change. Move then to a strategy for navigating change and uncertainty. And then I'm going to look at some modeling of resilience for a contrived system as really an exercise of fun and really learning about the system. And then last, I'm going to talk a little bit about, make some comments and summarize. All right, so let's look at this urban sets perspective. I'm going to borrow a statement from Billy from yesterday. Society, the reason for urban infrastructure. What we're really saying right there is you don't have people without infrastructure, and infrastructure doesn't exist without people. So what we assume is that urban areas are comprised of interdependent social, ecological, technical systems. And you can't separate them. In fact, you should avoid that, particularly when you're talking about resilience. The second point is that fundamental to managing urban systems is understanding the structure, services, functions, resources, interdependencies, and resilience of urban sets. All right, so here's some examples of different components that might be considered for social institutions, ecosystems, and technology systems. If we were talking and concerned about education, the resilience of education, we have to be concerned of where is it happening? Is it happening in buildings? Is there a transportation component? Can we get people there? How about communication and information? Maybe it's a distance learning component. So the whole idea is that we can't separate the two. In the reverse, it's the same thing when we're talking about the resilience of buildings. Which of these social institutions is most susceptible? And so the idea is let's not separate them, let's move forward thinking them as an integrated product. I want to point out that it's the case that we've talked a lot about risk and resilience, but we need to consider some of the infrastructure perspectives. The first being that infrastructure lasts between 50 to 100 years. And in some cases, we saw thousands of years long after the civilization has disappeared, so to speak, or moved. Other issues are that the right-of-ways also survive for footprint. The footprints survive for greater than 100 years. Urban sets today are highly connected and as a consequence susceptible to emergent collapse or even cascading collapses. And then today I would say that urban sets are very poorly understood and poorly monitored. A lot of work to be done there. Let's take it from the climate change perspective. We've all stated that the frequency of extreme events is increasing: precipitation, heat waves, hurricanes, winter storms. There's been projections of sea level rise of 1 to 4 feet by 2100. For Florida, that's a big difference. And in a state that doesn't recognize climate change, we're in for some exciting times. Going forward, there's a significant uncertainty over the location, magnitude, and the rate of climate change, which also makes it very challenging going forward. Climate change uncertainties increase when we look at the planning horizon. And last of all, climate change uncertainties increase when we try to downscale to scales of construction projects. That all said, the primary engineering challenges that I've identified for this moment, there will be more that will be added on, is that climate change will be more difficult to estimate at local scales and for the service life of infrastructure systems. Pretty cool problem, actually. Infrastructure systems of the future will need to be adaptive, and a new paradigm will be needed for urban risk and resilience engineering. And I would say one based on adaptive management of urban sets. All right, how are we going to navigate this change and uncertainty? Well, my proposal would be adaptive management of services and resources for urban sets to facilitate system-wide resilience and inevitable navigation of system failures. They're going to happen. We can't avoid them. And then the other aspect is there will be continued analysis of risk, return on investment, and cost and benefits. But I think the issue here is I think it'll be over short time scales for local venues and over long time scales for over regional areas. So, given we're looking at adaptive management, I had to come up with a definition of adaptive capacity and one that I feel comfortable with in terms of looking at the problems that we're trying to do right now. And in the example I'm going to present in a few minutes, For urban sets, the adaptive capacity is the collective intellectual, financial, physical, and technological resources combined with cooperative institutional resources that can be brought to bear on sets' adaptation to changing conditions. That's a lot. Okay, the last part is that we should invest long-term in building adaptive capacity. We've all seen plots like this where we're going through the various stages of services loss and recovery. It's also been suggested that the way we navigate these stages can be used as an indicator of resilience. And of course, if we're looking to promote resilience, I would argue that we need to navigate the adaptive cycle on a continuous basis. Communities need to do this, stakeholders, for building adequate or building urban adaptive capacity. All right, so now I'm going to go through a simple problem. It really is simple. The figures look a little more complicated than they need to be. I'm going to hypothesize that I've got a critical infrastructure network that's along the coastline. It's subjected to coastal flooding on episodic intervals. And in deference to Kirsten, what I'm going to do is recognize that as a result of the damages to the infrastructure system, it promotes unemployment. Okay? So my unemployment can range between 0 and 100%. These are all normalized. So it really represents maybe a 5 to 20% increase, 5 to 20% unemployment. So that's the loss of services I'm looking at, unemployment. And then I'm going to have another term called adaptive capacity. You can think of community resources. They're going to be able to apply to overcome this problem. And these adaptive capacities coming from all these social networks that are illustrated right here. Again, it's non-dimensionalized, going from 1 to 0. All right. So here's an example of some results. Time is down here, and the axis here basically has the episodic events, the adaptive capacity, and the unemployment. These little circles indicate the episodic flooding, which is disturbing our critical infrastructure system, it's damaging it, and as a consequence, we get a spike in the unemployment. In this case, this disturbance caused a significant spike in unemployment. And then to rectify the problem, our adaptive capacity is then used to invest back into correcting or fixing the system, as well as attenuating the unemployment. And so what we see is a reduction in the unemployment right here. And then it spikes again on another event. So you see the cyclic, and it's a non-periodic cycle of different episodic events which cause an increase in unemployment and then a recovery. And as a consequence, our adaptive capacity up here in the blue decreases and then recovers, decreases and recovers. And it makes sense. As people are employed, they increase the tax base, they can reinvest back in building up adaptive capacity. All right, this is another way to look at it. It looks a little ugly, but let me see if I can walk you through it. Okay, the horizontal axis down here is unemployment. It goes from 0 to 100%. This vertical axis here is the adaptive capacity, again going from 0 to 100%. Very easy to create these figures. I'll show you how it's possible in a few moments. We got some interesting areas. The blue area, which is good, and the bad area, which is bad. Okay? What happens is that if we have a combination of unemployment here, for example, and adaptive capacity here, we will migrate towards this stable point right here, which is about 25% unemployment and about 60% adaptive capacity. We'll always want to go there. We're viable. We can continue along this. This is where we want to tend to. We can do this anywhere as long as we're in the blue area. However, if we find ourselves in the red area, combination of unemployment between 0.5 and 1 and an adaptive capacity somewhere less than 20%, then we're susceptible to total collapse. Another stable point down here which represents 0 adaptive capacity and 100% unemployment. All right? Not good. All right. And then this transition zone along here, man, that's just a lot of opportunities for trying to look at a transition zone where if we fall anywhere between here or here, we could either be successful and adapt or survive or actually collapse. So they represent various thresholds, basically a line of thresholds in this two-dimensional map. This little point right here is a saddle point. I can talk about that later on. Pretty cool. Let's look at that a little bit second. What we have here are these dark lines right here. This represents the disturbance, the shock. and it caused a decrease in adaptive capacity because that would happen as a result of the destruction or the damage incurred on our critical infrastructure because of flooding. And then it continues to decrease, our adaptive capacity continues to decrease as a result of trying to decrease the unemployment, which is shown here, it's decreasing, and of course it goes back to where we expect. So an increase in unemployment, a decrease in unemployment, and then a recovery of the adaptive capacity. All right, let's look at another example. And in this case, it's the case of we got a collapse taking place as a result of an event that was so large, it caused an extreme amount of unemployment. And then what happens is that our adaptive capacity is being consumed to kind of recover that problem, or overcome the damage, but there's not enough there. So as a result, we continue along, we recover unemployment for a while, but then we continue along our process of collapse. And that is illustrated right here in this figure right here. Same thing, all conditions the same. This is adaptive capacity, this is unemployment. We get the severe disturbance. It causes unemployment. Unemployment decreases as we're spending our adaptive capacity, but there just isn't enough resources, and so it continues on in a collapse. That's the example. In the last couple of days, we talked about various strategies for creating going from fail-safe to safe-fail. Fail-safe, that was the hardening and redundancy strategies, pretty much of the time of old, but we're still going to use those strategies. They'll be used when they're most effective. What we've been really focusing is on adaptation, flexibility, and diversity. There's a bunch of options there, the rerouting technologies, modularity technologies, diversity, or strategies. Technologies or strategies that could be applicable to both social systems as well as technical systems. And there's transformation, another process where we redesign, we reinvent, or simply replace what we've got going. All right, so summary of results. The first is that resilience depends on one's perspective. I think we've seen that. And as a consequence, there's no agreement on resilience terminology and metrics. I don't expect that there's going to be. Innovation and diversity are fundamental to flexibility and adaptation, and in turn, the urban resilience. My statement right here is forget anything else. Talk sets, talk sets, talk sets. Just a second, sorry. The third one is bad decisions are emergent, stochastic, and unavoidable, and analogous to self-imposed system disturbances or changes that must be navigated. And then the last one is increasing urban adaptive capacity fosters urban resilience. At least that's what we hope. So we must invest in building system-wide adaptive capacity for long-term, and hopefully resilience will then follow. And I leave you right here with some suggestions on how we can build adaptive capacity. You guys are already doing it. Okay, so I'm now ready to open up for questions. Doctor.
So one of the points that is critical in what you've said that has been commented on and appreciated in the discussions, especially on metrics, is the idea that the adaptive capacity is a potential for future action, right? It's assessing the potential to act, to change how you do things today, right, when conditions, circumstances, variations, resources change in the future. Doesn't mean you're always changing. It means you have the capacity to recognize the need to change. And we've had occasional glimpses of this in the discussion. Roger mentioned it briefly on the first day in terms of reconceptualization or revising as being fundamental. But when we come to metrics, wherever Igor is, one of the problems is, and engineering and physics is full of concepts and measures that are about potential in the future, right? But fundamentally, the measure is about your future capacity to act when conditions change. And that is a fundamental thing we always have to work off of. It is not optional, it is not deferrable, it is not let's forget about it for right now. It's always about the potential for the future. We can develop metrics for that kind of stuff. Many of the shortcuts we're taking are violating that fundamental principle about the nature of things. So I appreciate you using these to bring it up.
Simple example in my mind is we save for the whole purpose of being able to address expenses in the future. If we don't do that, we're down there near the collapse point.
I had a question though, in terms of how you're using resilience. If you have the multiple stable states, which is a really nice illustration of how you can have alternate states in the same system, and if resilience has a kind of directionality or a normative component in terms of thrive or something like that, it then excludes using the word resilience to talk about that alternate stable state, which is in fact, choose another word than resilient now to describe that state that is resistant to change, it's persistent, whatever. So I guess in your own work, my question is how, if resilience becomes a word or is becoming a word that is used to describe a preferred state, how do you describe that other state? What words do you use? What language do you use to describe that alternate, very stable state?
Well, that's a good question. I don't know that I have the words for it. I think in the context that we could be where we are today, and then something could happen to shift us, and we're in an okay state today, but something could shift us in an even better state, and we haven't talked about that transformation to move in an altogether different direction. And that would be, in my sense, and also a reflection of resilience, that we're moving in.
What is the difference in defining resilience or calculating resilience and adaptive capacity? How you do that here? Are you doing that as some kind of product of metrics?
So I'd say, to me, resilience is an outcome. It is a response, and adaptive capacity is a potential for visiting these outcomes.
But if it's outcome, you cannot quantify it, right? You cannot. You can quantify outcome.
Oh, I could say over time you can.
Yeah.
Yeah, over time.
Great stuff. Resilience is the one thing that I disagree with you. It's that resilience is not an outcome. Resilience is a process.
Mm-hmm.
As I said yesterday, there is a lot of people that now are in the process of resilience, and communities that are in process of resilience. When we are talking now because of climate change, we only consider that resilience is when we have these spikes. But as your own work shows, actually we are going on the process. It's a process.
It's a continuous process.
It's a continuous process right away,
Right.
first of all.
Right.
Second, I like the stuff, the basing of, because for instance, the sketch of the theory that I presented yesterday, it's really can putting in this basing of attractions, and because we can multiply the different factors. Employment is one of the factors that you put, but stress, control, whatever, in the different subsystems, we can put it over here and over there. Then basis of attraction could be very interesting, and I think that we can quantify it, and that is the most. But we have to be clear in about what are the system, the scope of the system at each time that we want to do the basing. What are the systems that we are talking about, and for that system define the factors and put it in that basin.
Agreed, totally.
But be very clear in this stuff. And it's not an outcome, it's a process.
But if resilience is a process, what do we quantify? Ability of the system to perform this process through a series of metrics reflective of system ability to perform this process, or something else? And then if we do quantify an ability of the system to perform the process, how it's different from adaptive capacity? Because it's same, it's part of some of the abilities, like, back to Dave's, resilience is like a bunch of abilities that we quantify, right? Anyway, just...
Okay, well, let's continue this discussion with the whole group. Do you want a quick response while we change it?
My parting comment is only if we can put it to the music of Vivaldi.